So now the question is how do I know if the substance is a good conductor of electricity or a poor conductor? Like in the previous lecture, I gave you a few examples of good conductors and the poor conductors. For example, I said that water is a good conductor, and I said that plastic is a poor conductor. But there are so many other substances which we see around us. Now, how do we know that which one will allow electricity to pass through it and which one will not? For that purpose, we make use of a device called tester. So the job of this tester is to test the conductivity of a substance, whether the substance is a liquid, solid. The tester can test the conductivity. So it's a device or a setup to test the electrical conductivity of an object. So when I say electrical conductivity, conductivity means the property of a substance to conduct electric current. So now, how well or how badly a substance allows electric current to pass through it, that is what we mean by conductivity of an object. Now, if you want to know how exactly a tester looks, you would have seen testers in our science laboratories. In fact, you can build a tester of yourself. And how that tester would be, I'll show it to you. So let's suppose we make a setup. We make a setup where we take a bulb, we take a battery, and or cell. We connect them, and we have a switch. And to this in the circuit, you know how to connect all these, as we had learned in the previous lectures. Now, in between the circuit, you also connect the substance, which we want to know whether the substance is a good conductor or a bad conductor. Now, in this case here, this substance is a metal. So, maybe any metallic object. Now, what do we want to do? This circuit will actually act as a tester. So, this circuit will tell us whether this object, whether this metal is a good conductor or a poor conductor of electric current. So, what do we do? You switch it on. Now, as soon as you switch it on, if this object is a good conductor, so in that case, it will allow current to pass through it, right? Then in this complete circuit, current should be flowing and the bulb should glow. So here, what do you see? The bulb glows as soon as we switch it on. So when we switch it on, circuit gets completed. So um, uh, path is provided for the current to flow. Secondly, since all these materials, the wires as well as objects, they all allow electric current to pass through it. That is also a reason that the bulb could glow. So this shows that this object, metallic object, is a good conductor. So we can say that metal is a good conductor. Now let's say we take another substance. So the same circuit, which will act as a tester. So the same circuit, but instead of metal, now we have a plastic object. Now, what happens? Again, you switch it on. Now, when you switch it on, the circuit is complete, path is complete. But since this object doesn't allow electricity to pass through it, and therefore the bulb did not glow. So now, if the bulb glows, that means the object is a good conductor, and if the bulb doesn't glow, that means the object is a poor conductor. So we can say that this object is a poor conductor of electricity, and this is a good conductor of electricity. So this is how a tester looks like. And this can be your tester because you can create this simple circuit with the help of a bulb and a battery. Now, how exactly a tester looks, which you see in your laboratories? You would have seen the multimeter like this. So they are used for many purposes. Just one metered box, but it's actually used for measuring current, for measuring voltage. So it has multiple purposes, but it can act as a tester as well. So normally you would see there are two leads, the red and the black leads. These are free ends. Now, whenever you want to test something, so what do? You will connect this tester through these two free ends. Let's compare this tester with our tester, the simple tester which we created. So you saw that we have connected two terminals of a bulb to two terminals of battery. But what we did, we didn't join them. We didn't join these two wires because we did not completed the circuit. So these two would be the free ends of the tester. Now, whichever substance we want to check or we want to test for, so what did we do? We connect these two free ends of tester to that substance, right? Now, how do we test that the tester is working fine? So testing a tester. So how do we test a tester will work fine? In that case, instead of taking another substance, we just join the free ends of the tester. Now, when you join these free ends of a tester, the circuit becomes complete because the bulb should glow, right? Because the circuit is now complete. So whenever you join the two ends, circuit will get complete and bulb will glow. So if the bulb glows, that means the tester is working. And in a similar way, you can test the tester which is present in your laboratory. Just join the two ends of the tester and you will see that some reading should be shown here. That is, some current should flow through the internal circuit. So that is how we can check if the tester is working fine or not. So now that we know we have a tester with this tester, we can test the conductivity of a lot of substance, and we are going to do that in the next few slides. So we are now ready with our tester. Thank you.